Welcome back. As the semester draws to a conclusion, I'm here to summarize the course and the progress so far. In this course, you learned, with your curious minds, the framework for understanding and applying the state-of-the-art machine learning models on business problems. You learned a few classic models under both the supervised learning and the unsupervised, unstructured learning algorithms. And above all, you learned and tried to apply one of the most comprehensive machine learning models, the deep neural network models, on suitable business problems. I am very proud of your achievements so far, and as we have 2 weeks remaining for this course, I would like to draw your attention to the remaining work to be done, and I expect you to pay attention to and apply diligence in completing the remaining portion of the course with the same level of standard and quality. For the remaining of the semester, your work includes mainly the final exam and the final group project. The date and time for the final exam has been communicated in the syllabus, and please check the details in the syllabus. To help you prepare, I have made available a practice set on Blackboard. In the future, it will be on Canvas. Feel free to download and practice a few questions that will be similar to the questions that will appear in the final exam. But do pay attention to the notes regarding the practice set while you download the questions. And good luck with your final exam. Now, regarding the final project, the structure and process will be quite similar to several of the homework and class demo problems throughout this course. Under the supervised binary classification problem, nonetheless, there are a few additional challenges that are unique to this group project, and I would like to highlight the essence of these additional challenges for you to be prepared as you start and dive deeper into the final project process. The first of such challenges is regarding the region variable. The region variable is a numeric variable. However, you are advised not to treat it as a regular interval or continuous variable because of the meaning of this variable. This region variable records an arbitrarily assigned number for a geographic region of the country from which the dataset is acquired. These arbitrary numbers are not proportionally or orderly related to the actual geographic regions for which the numbers are coded, and therefore these values are best treated as discrete labels for the regions instead of some meaningful quantity about the regions. Besides this, an additional challenge would be that there are quite a long list of unique region values, meaning if you were to create one-hot encoded columns for each unique and discrete region value, you would probably end up with a subset of flag variables that has a large number of columns. I'm not saying this is not feasible, but when you have a large number of columns in the result of your one-hot encoding step within the column transformer preprocessing stage, you will probably end up with a sparse array data objects based on the scikit-learn transformer process, and the codes that are provided and demoed in class may not work smoothly because this time you are not dealing with a regular array but a sparse array data object. To solve the errors, you can leverage the .toArray method of the array objects to return a regular dense NumPy array and be able to use the codes that are provided and demoed in the course materials. Now, I have talked about one way of dealing with this challenge, But alternatively, a smart data scientist might use exploratory data analysis, EDAs, and summary statistics to look into the distributions of the discrete categories of the region variable, and soon to find out that there are only a few regions that dominate the dataset. Many of the other discrete levels of the region variable are only the minority cases. And in those situations, you might find it worthy to recode all of the minority region categories into one union label created to be differentiated from all the levels existing in the region column. And this recoding process will produce a more concentrated region variable. And based on that recoded region variable, you can use the one-hot encoding and not encounter the many columns problem. But this latter solution will require you to be better versed with using Python programming language to deviate from the processes that are covered in the classroom. It is your team's discretion to choose which strategy to go about this challenge. The other challenge I would like to highlight is the class imbalance problem. In this dataset, the two classes in the target variable are not equally weighted. One class is the majority class, while the other is the minority class. This creates a challenge for the machine learning algorithm, even neural networks algorithms, to learn efficiently and avoid being a victim of the class imbalance issue. So I like to remind you that one efficient way to deal with this challenge is to make use of the class weights parameter setting in the Keras sequential model fitting process. Essentially, you will be providing a setting to the model fitting process by which the penalty applied to the errors made on each of the class unequal. In plain language, that means that you can tell the model to be more sensitive to the mistakes made on the minority class cases so that the model can learn more efficiently and more effectively on those cases that are the minority of the data set. By doing that, your model could be able to mitigate or at least decrease the negative influences of the class imbalance problem. Alright, I hope these tips will be able to move your team more smoothly through project process. And finally, good luck to all of you on your final exam and your group project. And feel free to reach out to me as well as your TA whenever you have a concern or challenge or questions during these activities toward the end of the semester. See you by now.